Hi, welcome to another video of my riding carriage on tracks with a sonar, fischertechnik robo interface connected to the BeagleBoard. The BeagleBoard runs Ubuntu Linux for ARM. And last time I experimented both by putting this on an elevation as it is now. The results were mixed because despite of the relatively low resistance, the distance that it drove or rode on the tracks were different. It either stood still or rode half of the track or the entire track, but nothing consistent. Then I used this metal rod, equal of length of this, and that turned out to be a speed changer. So what I'm going to do is removing this elevated track for now and put the iron tracks on them, and with that speed, which is, as it turned out last time, almost too fast, see if this sensor can be touched by sheer speed. So let's do that. Taking this off the tracks. That's one. That is two. Oops. Now this track is done. However, the sonar needs to be put down, literally put down, on a distance like this. I think it's okay. And then the carriage, keeping in mind that everything has to be on it, like this. Then I want this sensor to be fixed somehow. Maybe this is a way, although I doubt it. So let's see how I can get that to work, because I want it to be elevated so it pushes right this way. And while doing that, I see another problem, because like this the connectors are in the way. So it would be either something more like this, and this is way too low. So that needs some elevation as well. And not something like that, but like this. So I need some parts to fix the sensor. I've made a construction here in which this sensor should fit. And not only that, it should be on a position that it would be touched by the carriage. However, here is not happening. So I put another one of this block here. Then again the sensor. Now let's see what happens. And now you already see that the underground is moving. So now I'm very curious what will happen when I activate everything. So let's put the lamp here in the shade so we can see the light if it happens. And let's see what happens. So let's run it. Yeah. And it's all nice. It works better with all wheels on the tracks. So I might put something next to the wheels to keep them at their places, but let's first run again. And that is what I meant. Now if I is it actually touching the sensor? I doubt it. I seriously doubt that it is touching the sensor. It is more like bouncing against something. So this is not really ideal, and I need these wheels to be like this and not something like this or this. So I need to put something in between here, and that goes for all wheels. And when looking at the tracks or at the carriage, it is a little bit flexible, but should that matter? I don't know. It is very lightweight, that thing is clear. So my previous attempt, which I showed in the last episode, of putting a wheel here under the tracks, might be a solution, but then I have to elevate it again. Let's run it one more time. It is bouncing. It is really bouncing off the end. So this is not really a solution. Okay, let's stabilize the wheels. That is a better idea for now. So the idea is to put one of this next to each wheel, which comes down to taking one out and this one should stay at the side. Put this one in if possible. Yes, it still runs, so that could be possible. This way the wheels won't, how do you call it in English? Swagger. Well, it's giving me a bit of a hard time, but there it is. And now there's a little bit of a problem, because each side must be equal to the other. And now this one looks okay, this one be a little bit wider. This it's a little bit fine-tuning, but I hope that it will be like this and stay like this. Now let's see if the speed is still there, because that is another question. Oops. And that is clearly a problem. It bounces off the tracks. So it is quite clear now. Oops. Okay. This is not working. You can see that there's now distance between the fan and the cone, which should be 0 of course. And these wheels are giving problems. So despite the fact that I eliminate the flexibility, it doesn't run as intended. Let's see if this works better. When I put them just on half, let's just see. It doesn't even run as easily. It doesn't even run as easy, despite the fact that it just runs smoothly like this. So I think that this is in itself a good idea. However, when you look at this, it is not the same. Oops, there goes the wheel. So the carriage is too flexible on that, I think. And another point is that it is clear that it is bouncing off the whole sensor, because it will work, but not like this. Another idea is to use a light switch. So a lamp that shines on a light sensitive transistor and then interrupting the light beam, and you know that you're on the other side. And with that, I think I will remove this as an idea and have the light switch going, and I'll put this one back because that is still better. So the new idea is a lamp which is a special lens lamp, so it focuses the light, which is then received by this transistor, phototransistor. This is the wire that the touch sensor was on, because it replaces it. This wire is from the lamp, and the lamp needs to be put on an output, just like this lamp is. So I will use this one, and I will have to put it on mass. Apart from that, this is the now useless sensor, but I put it here to avoid that the carriage is running off the tracks. So it will bounce, more or less, maybe. And with that, it becomes like this, and it passes the light which it should pass, but it doesn't. It runs against the lamp. So this means that the distance has to be further, and I will need one more of this next to this one. It will be like this. So apart from that, it will run like this, interrupt the light beam, and by interrupting the light beam it will reverse the direction of the fan, which will run like this, and go by sonar, etc. So it should do this, and then hopefully not getting off the tracks. And if it keeps being unstable, I'll have to deal with the construction of the carriage, because needless to say, I don't want it off the tracks. Another thing I should do is reprogram the whole thing. This lamp is only on when this light is interrupted, but this light needs to be on at all times. So that will need to be some reprogramming. And with, apart from the extension of this part here, is there more to do? For now, I don't really think so. So let me first extend this part and then onto programming. Okay, so some time to program. Digital 8 is now no longer the touching sensor, but it is the light sensitive transistor. These ones I will delete. Oops, come on. Then this is the ordinary lamp. However, what I need to do is to keep the lamp, which is the lens lamp. It is on output 5, but it needs to constantly on, so I will put it here. And this is 5. And let's see what happens if I let it sleep for 1 second. Just testing. And now, of course, what happens if it is not, because the light beam is interrupted. Yes, let me test this. Just a dry run, see what happens. And of course I need to save this, otherwise it won't run anything. And I'm just doing this manually. And I've let it loose and it's getting off the tracks. But apart from that, I'll have to watch it, what happens exactly. And there I see a problem, because the light sensor is a little bit early. The carriage can run further than the light sensor senses. So I need to put the light sensor further back. Let me do that straight away. Just by testing it and then see what happens. There it goes. And that's a lot better. So does it actually run like this? Let's see. No, there's another problem. Let's see, I hold it right now and it keeps just running, and I put it in front of the light sensor and it just keeps doing it. There's another problem as well, because I don't see the light sensor not burning.
that is supposed to be doing. So let's put this on 2. Does it run? Does it work? Oops, I mean this one. It is 0, and let me put another thing on. If not digital, 8. So in the other hand, let me put what it is here. Just trying again, just trying. And of course not, because it is outside the while loop. So I need to figure out how to do this. But first let me show you again on cam how it looks like.
So, as you can see, I've put another block here, and I put those a little bit to the back side, light resistor and lamp. So if I put that now back, it reaches the end, and oops, and then it should interrupt the light beam and go that way. However, this lamp should be burning at each time, or just continuously. That is the whole point. So let's try once again. Because this light has to be burning at all times. So I'm placing it within the while loop. I think that should be a lot better. Now run it again. I'll have to restart the terminal. There we go. See, now the light burns. But what does happen? And this is more... No, this is not what it looks like, because although the light is burning now constantly, this one should only burn in this situation, and that is not what it looks like. That shouldn't be too much of a problem. What is a problem is that as soon as this light beam is interrupted, the fan should be turning the other way, and that is not happening right now. So yes, and that is because the distance is only turned when the distance, or the fan is only reversed when the distance is larger than 5 centimeters. So it doesn't even respond to the light. The light is only responding to this. So that was a misthinking of me. Which does not mean that I can't change that, because I can easily change it whenever it interrupts the light beam. But I think that is a nice one for next time. So far it looks stable. And that is, well, so far a nice experiment. So for now, thank you for watching, and to be continued.